We're going to talk all about slope. And on Friday, I told you that we were going to talk about slope just a little bit early, because I think using slope to graph is something that we've done a lot of, and it made things a whole lot easier to graph in some situations on Friday. So that's why we've already talked a little bit about slope, but we're going to go a little bit more in depth with slope today. We're going to talk about how to find slope in different scenarios. We're going to talk about different types of slope and what they look like and what they mean. And then we will talk about some scenarios where slope is used. Okay, so first of all, I could give you a lot of different ways to represent slope, right? When we did it on Friday, we did it to help us graph a linear equation. And really, linear equations is the only time that we use slope. If I'm going to do like quadratic equation or some other type of graph where it's like a parabola, or yesterday we saw some real crazy different graphs, we don't really use slope. So slope is only used when we have a line of some kind. If I were to give you a table of values, one way that slope can be represented I'm going to give you some x values. And I gave you some y values. Okay, there's 3 questions that you're going to answer here. Okay, first question. Is the change of x the same, going all the way down? So as we go down the table of values, from one x value to the next, from 2 to 4, we're going up 2, up 2, up 2, up 2. And so every value, and make sure they're all the same, every value is going plus 2. So we would say yes, those are all the same. Okay, second question is the change of y the same? Once again, we look at our y values, and as we go from top to bottom, from -8 to -12, we're going down 4, down 4, down 4, down 4, all the way, okay? So we're going down 4 all the way down, and so this would be -4, and so we would say yes. Okay, the third question is this linear? And in order to answer that question, if I say yes for both of these, then I would answer yes for this. If either one of these happens to be no, then it would not be a linear function. Both change of x and y have to be the same value. So we would say yes because both x and y are the same. They don't have to be the same number, but they have to be the same change all the way down for both. Okay, like this one happens to be +2, this one happens to be -4. If I wanted to find the slope here, slope, remember we talked about on Friday, is represented by lowercase m. So lowercase m is one we're going to see a lot today, but we're also going to see it throughout the year whenever we talk about slope and linear equations. Whenever we do slope, it's always the y values over the x values. Okay, and on Friday we talked about rise over run, and I spelt rise with a y because that helps me to remember that the y's go on top. Same thing here, change of y over change in x. So if I wanted to find the slope here, the change in the y value was -4, the change in the x value was 2, and so my slope here would be -2. if I were to graph this function would have a slope of -2. And we're not necessarily graphing this one, but that's how I could find the slope without looking at the graph, if I didn't have a graph especially. Okay, so that's one way of determining slope, is just looking at the change from x's and y's. Okay, probably the one that you remember the most from talking about slope is using the slope formula. Once again, here if we're doing the slope formula, we do y2 minus y1 over x2 minus x1. I'm going to give you two ordered pairs. And we're going to label those two ordered pairs x1, y1, x2, y2. So if I gave you two ordered pairs, and let's say we have 6, -3, we have 7, 9. We're going to label these 4 points. 9 minus -3 over 7 minus 6. The biggest thing you got to make sure of is, and it really doesn't matter which one's x1, y1, which one's x2, y2. I could also label this one x1, y1, and this one x2, y2. So they could be flip-flop. But you got to make sure you go in the same order. So I got to go 9 minus -3 and 7 minus 6. What you don't want to do is go 9 minus -3 and then do 6 minus 7, because that would change my slope. It would be a little bit different answer. So make sure you stay in the same direction as you do your subtraction to find your slope. So in this case, we simply just get 12 over 1, which is just 12. So those 2 points would have a slope of 12. Some people might say, well, I could just plot those 2 points and find the slope between them and do rise over run. And you could do it that way. And that is one way to find slope. But I probably wouldn't do that unless I have the graph provided to me. Or especially if I don't have a piece of graph paper, right? If I don't have a piece of graph paper, do I really want to take the time to plot those 2 points, find the slope by doing the rise over run? But if I already have a graph, then that could definitely be a great way to do it. And so that's the next thing that we're going to talk about. What if we have a graph provided? And I'm going to go ahead and put a piece of graph paper up here. Okay, there's a couple of different kinds of slope, and we're going to kind of talk about those here. First of all, if I was to give you a graph and we wanted to find the slope of this, then what we do and here once again, rise over run is something that we could use. On Friday we had the equation, so we used rise over run to graph the equation. Here we have the line, but all we're looking for is what's the slope. Okay, so we're going to go from one point to the next. So to go from one point to the next, we're going to go up 3, and then we're going to go over. So we're going to count. So this would be a positive 3, and then 1, 2, 3, 4, 5, 6, 7, 8. And it'd be 8 to the right. So our slope here, my rise is 3, my run is 8. If it reduces, we would reduce it. If not, we leave it alone. And that's our slope, 3 over 8. Okay, we call this a positive slope. The line is moving up as it goes to the right. So if you have a line that is rising, is going up as it moves to the right, your answer will always be positive. Okay, the numbers are going to change. Okay, how steep is it? Right? There's all kinds of situations where we use slope in everyday life. Obviously, you might hear like ski slopes, right? Some ski slopes are a little bit steeper than others, and so they have different levels for different levels of skiers. But you can think of things like a roof on a house, right? It has different, like you look at the school building. The school building doesn't have a peak on it, right? Well, the reason it doesn't have a peak on it is because it's so big. The school building is an entire city block essentially. So does that mean that the roof is not sloped? No, it has to be sloped, because in order for the water, if it rains 3 inches, we gotta get that water off the roof, otherwise it sits on the roof and it causes problems for leaks and things like that. So it's just got a really gradual slope to it. If you went up there, you probably wouldn't even be able to recognize that it has a slope. Same as like a roadway. Roadways have slope to them. It's not a very significant slope, but if you watch it rain really heavily, if you're out driving, then you'll see the water going off. And it goes right into the ditches because they don't want the water sitting on the roadways. That's going to be a big hazard for the drivers. Handicap ramps, right? Handicap ramps have to be made at a certain steepness. If they're not made at just the right steepness, then the contractor would have to start all over. Okay, so they have certain specifications they have to meet. They don't want it to be very steep for a wheelchair to be able to go up it. Sometimes they can get grandfathered in, but most of the time, if you're building a new building and you're putting a handicap ramp alongside the building, it has to meet certain specifications. Okay, another type of slope. Okay, this one here, we are going down and then over. So we're going to go down 1, 2, 3, 4, 5, 6. We go down 6 and then over 1, 2, 3, 4. So when I write this slope, make sure you always put your rise on top, okay? So I always like to go left to right and then either decide, am I moving up or am I moving down? Up or down is my rise. In this case, my rise would be a -6. My run would be 4. This one, we can actually reduce it. 2 goes into both of those. And so that would be -3/2. That would be our slope. Okay, when we write slope, we would probably choose to write slope most of the time as a fraction. Okay, it just makes the most sense. Rise over run. You might see like slope identified as like a decimal in some cases in an equation. Kind of depends on the situation or if there's a story problem, but fractions are usually the best way. -1.5 wouldn't be wrong. It's just not usually the way we typically would write it out. Okay, so positive and negative slopes. This one would be an example of a negative slope because as the graph goes from left to right, the graph is going down. It's dropping. Okay, so all graphs going left to right that drop will have a negative slope. The number will change, but it'll still be a negative answer. Okay, so immediately you should be able to look at a graph and say that one's either positive or that one's negative, and then you got to figure out what the actual value would be. Okay, now we have 2 other kinds of slope that we're going to see. If we have a line that is horizontal, in this case, what would the rise be if I was going to go from one point to the next? 0, okay? My rise is 0. And my run, it really doesn't matter. In this case, if I was going to go from the 2 points that I made here, 1, 2, 3, 4, 5, 6, 7, 8, but it really doesn't matter what's on bottom because 0 divided by anything would still be 0. So a horizontal line will always have a slope of 0 every time. A vertical line is the 4th kind of line. We have positive slope, negative slope, 0 slope, and then this one here, my rise is 6. My run is 0. What happens when 0 is on the bottom? Nope. It's an error, right? And that's kind of like what we talked about with our evaluating yesterday, is that we can't divide by 0. If you tried putting 0 in your calculator and taking 6 divided by 0, your calculator is going to say, hey, you can't do that, right? It's going to say error, or it's going to say undefined, or it's going to give you some error message. And so that's what we say here, is that anytime we have a vertical line, our slope will always be undefined. Okay, so those are your 4 different types of slope. First thing when I see it, if I see vertical and horizontal, immediately I should know what they are. If I see positive and negative, I'm going to have to find out what the actual value is, but I should at least recognize that it's a positive or a negative slope. Okay, on Friday, we went ahead and talked about y equals mx plus b. Today, we're not necessarily going to graph the line itself. We're just going to look at the equation and say, here's my slope. Okay, and if it's in slope-intercept form, man, piece of cake. Because if I said y equals 2/3 x plus 7, the 2/3 is my slope, 7 is the y-intercept, and my slope is simply just 2/3. That's all there is to it. So if it says find the slope, there's nothing to do. All you got to do is look at it and say, yep, I know that's the slope, and we're done. Okay, the other equations that are a little bit harder to do. First one, the line x equals 2. If I said, what's the slope of the line x equals 2? That's a little bit harder because it kind of looks like it's in slope-intercept form, but it doesn't have y by itself, right? And so it's obviously a little bit different. So here's how we would graph it. If I have the line x equals 2, that means all of my x values are 2. So I could do 2, 0, 2, 1, 2, 2, 2, 3. I could keep going, right? All of my x values are 2. So my graph is going to look like that. And we just did this one, right? I have a vertical line. A vertical line has what kind of slope? Undefined, okay? So this would have an undefined slope. You don't necessarily have to graph it, right? If I see an equation that's x equals with no y in it, immediately I'll know that it's always undefined, okay? Now, if you needed to graph it to kind of give you a visual of what's going on, there's nothing wrong with that, but just know x equals whatever is always an undefined slope, vertical line. Okay, so then the other one that we might see is y equals 3. Okay, y equals 3 is going to be just the opposite. We're going to go up 3, so it's going to be like 0, 3, 1, 3, 2, 3. All of my y values are 3. Okay, and what we now know is this is a horizontal line, okay? And because it's a horizontal line, what do we know the slope is going to be? 0, okay? So this would be slope of 0. So all vertical lines will have an undefined slope. All horizontal lines will have a 0 slope every time. Vertical lines will always be x equals something. Horizontal lines will always be y equals something and have a slope of 0. Okay, another way to kind of remember this too, x equals 2 means it crosses the x-axis at 2. So that's a really quick and easy way to remember that. Okay, I know that it's crossing the x-axis at 2 because it's x equals 2. Here, if it's y equals 3, it means it's crossing the y-axis at 3, and it never crosses the x-axis because there is no x value. Okay? So standard form is a little bit harder. We saw standard form on Friday, and we said that it's not real easy to graph because the numbers in standard form don't necessarily mean anything. So once again, standard form, the basic form of standard form is ax plus by equals c. the A, the B, and the C are not representing anything. They're not your slope. They're not your y-intercept. They're not anything, right? They're just numbers. So what we're going to do is I'm going to give you an example. Okay, I'm going to show you two different ways to do this. I'm going to show you kind of a shortcut, but I'm going to show you one way we can do it, and then I'll show you the shortcut to it. Okay, for the first one, I'm going to give you 2x minus 6y equals 12. Okay, one way to do this is to solve for y. We want to put this into y equals mx plus b form, just like the last one was. And in order to do that, we have to solve for y. When we graphed this last week, we did cover-up method. Well, cover-up method doesn't really help us here because it doesn't help us find the slope. It gives us the x and y intercepts, and then we can graph it based off those two things. But it doesn't help us find the slope. Okay, so if I wanted to solve for y on this equation here, what would I do first? What do you guys think? Subtract 2x. Okay, so that would give me negative 6y. I always like putting the x in front when I put it in slope-intercept form, so that would be negative 2x plus 12. It's not wrong if you're right, 12 minus 2x, but I always like putting the x in front. And then I got to get rid of the negative 6, right? So we're going to divide by negative 6 all the way through. So then we have a negative and a negative. It's going to make it a positive. 2 over 6 reduces to be a third. So 1/3 x. And then 12 divided by negative 6 would be negative 2. Okay. The good news here then is that now it's in slope-intercept form, and the number in front of our x is our slope. And so that'd be our answer. Okay, so here's the trick. And then I'll give you another one, and I'll show you how this can be really helpful. Whenever an equation is in standard form, you can remember this little shortcut. It'll always be the opposite of A over B. So if I go back to this original equation we started with, the opposite of 2 would be negative 2 over B value, which is negative 6, is negative 2 over negative 6, which is really just 1/3. Okay? If I were to give you another example here, this is A, this is B, and this is C, but we don't really care about the C value here. We're not using it at all. All we really want to be able to identify is A and B. So if I did the opposite of A over B, the opposite of A would be negative 4. B is negative 5, so this is going to be negative 4 over negative 5, which is 4. A much quicker and easier way to find the slope, rather than having to go through all the work over here of solving for y. Essentially, you're doing the same thing. Okay. So, standard form, not ideal to find the slope, but that shortcut definitely makes it a lot easier. Okay. And this one here, this kind of goes back to what we did yesterday. F of negative 2 equals 3. F of negative 1 equals 9. It's given me some information in a little bit different format than what I'm typically used to. Yesterday, we did some problems like this where we said when we evaluate a function at negative 2, this would be the output, right? Input, output. And what we talked about the input and output was the number that we put in is considered to be our x value, the output is considered to be our y value. So this is really the same thing as giving me an ordered pair of negative 2, 3. Here, when I plug in negative 1, I get 9. So it's just a different way of giving you an ordered pair. or in this case, a set of ordered pairs. Now, our goal is still the same. Today is everything is about slope, finding slope. That's going to be what most of your problems are going to ask you to do today. I want to find slope. What would be the best way to find the slope here? Slope formula, you bet. Okay, we're just going to go x1, y1, x2, y2, and we're just going to plug that in to that formula we did at the beginning of the lesson. We're going to go 9 minus 3 over negative 1 minus negative 2. And then negative 1 plus 2 would be 1, and so we get a slope of 6. Okay. There's a lot of other things that we could do. Graphing it is probably not going to be ideal, but using the slope formula would be definitely something that would be good to do here. Hey. Thanks. All right, that covers it for slope today. I'm going to put the assignment up here for you. Okay, we're going by fours. So once again, we're going to start at number 1, add 4 to it, which would be 5, and then 9, and then just keep going up to 37, and then 49 and 55 at the end. So I think yesterday we went by 5s, today's by 4s.